I today. You guys have seen I before. Who remembers what I actually stands for? -1. Not quite -1. Square root of -1. It is the only way that we can actually figure out answers that have radicals of negative numbers, even radicals of negative numbers. So I is the square root of -1. And i's kind of work in a cycle as we simplify through things. They are going to start to eventually cancel out on stuff. Because like we just said, I itself is the square root of -1, which we can't simplify any further. If we do I squared, that is the square root of -1 squared, right? So what is I squared? -1. It is the only thing that when squared gives us a negative, is I. That's what makes it imaginary. Because it's not a real thing. When we do I cubed, square root of -1 cubed, what's that going to be? Yeah, we could break this up into be square root of -1 squared times square root of -1. I can do that, break my power up, because that's going to give me -1, I squared is -1, square root of -1. Also known as minus I. So I cubed is the same thing as the opposite of I, negative I. I to the 4th, what's I to the 4th going to be? 1. So we have square root of -1 to the 4th, which is going to give us square root of -1 squared times square root of -1 squared. I'm just writing it out this way, breaking it up into pieces, so that we can see what's happening here. Because then we wind up with -1 times -1, which is a positive 1. When we're dealing with i's with exponents, these are the only options we have. I, -1, -I, and 1. Those are the only things it can simplify down to. So when we're simplifying something like I to the 5th, we're going to use exponent laws, kind of like how I did, but less messy up there, and break them apart into products, basically. So I to the 5th, I could break up to be I to the 4th times I, right? That means the exact same thing. I to the 4th, we just talked about, equals what? 1. So this is really 1 times I. So I to the 5th simplifies down to be just I, with no extra bits at all. I to the 6th, we're going to do very similarly. I'm going to take I to the 6th and break it up into be I to the 4th times I squared. I want to pull out as many I to the 4ths as I can, because I to the 4th is just 1. So our I to the 4th turns into a 1, and then we're left with our I squared, which is -1. So we have 1 times -1, meaning the simplified version of I to the 6th is just -1. Okay? Do we see that, or did I just say I'm confused? Do we see that? Okay, we're going to practice this a little bit more, because they love to give it to us in homeworks kind of like this, but they're going to use much bigger exponents. We're going to practice with some bigger exponents. And we're going to use our exponent laws to kind of expand stuff outwards. But questions on this part? Expensive poster on the second part. Okay. Like I said, we're going to practice with some bigger numbers here. So we're going to simplify I to the 23rd. Stop calling. All right. So we're going to start with this I to the 23rd. I want to break this up into pieces. And I would really like as many I to the 4ths as we can to come out of that because we know those are just 1, right? So how could I divide 23 up into a product that will let me cancel out some I to the 4ths? I feel like I worded that very strangely. If I split this apart to be I to the 20th times I to the 3rd, that is the exact same thing as I to the 23rd. It's just broken into 2 pieces. We like that because if we think through our exponent laws, I can rewrite I to the 20th as I to the 4th 5 times, right? Exponent laws? Told you those come back into play. All right, the 3rd still just going to sit here for a second. I'm just dropping him down and we'll think about him later. Because I to the 4th equals what? 1. So this gives us 1 to the 5th times I cubed. What is 1 to the 5th? 1. So now we're just down to our I cubed. And we just have to simplify this piece. And that's a lot easier to simplify than I to the 23rd. We just did a whole bunch of them. I to the 3rd simplifies down to be what? Negative I. So the fully simplified version of I to the 23rd is just minus I, negative I. And you don't have to write every single step of this, but I was just trying to make sure we could follow the train of thought because it's kind of awkward to jump in the middle of it somewhere. Questions on this first one?
What was 5I again?
I to the 4th is 1. So we wanted that here. Oh, but you look on the last one, I to the 5th, simplifies down to just the I. Because we had I to the 4th times I, and I to the 4th is just 1. We're going to practice this some more. All right. So let's look at I to the 82nd. How can I divide 82 up into some smaller pieces to try and get something to cancel out?
20 times 4.
Yeah. Jumping a step on me, but that's absolutely okay. And that's if that's what you do on paper, 100% okay. Okay? I'm just going to write more steps up here. So I can, whoa, wrong pen. I can divide this up into be I to the 80 times I squared. That means the same thing as 82, right? Because if I'm multiplying the bases, I add my exponents. We're dividing it into 80 because I know that 80 has a factor of 4. So I can rewrite I to the 80 as I to the 4th. How many times? 20 times. And we have an I squared over here. I to the 4th is just 1. So this is 1 to the 20th times I squared. And 1 to the 20th is 1, which means it doesn't actually have any impact on anything. So we're just left with our I squared. And what does I squared simplify down to? Negative 1. Because I know it's been a hot minute since we dealt with I, and they're weird to re-find in our brain. So we're using our exponent laws to get it as simplified as we can.
So is I to the 80th, like, and I to the 20th, is that equal?
Yeah, because I to the 80th, I just split this apart to be 4 times 20 because I want to have a 4. I want to have a 4 because I to the 4th we know is 1. Go away. So I to the fourth is 1. That's why we're aiming for 4s. I want to find a 4 in there somewhere. Because I to the fourth is 1, which means it's out of my way and it's no longer impacting anything. So I want to remove as many I to the fourths as we can. So we're looking for something in there that we can divide by 4 so I can get I to the fourth to cancel out. So how about I to the 36th? What can we do with that? 9 and 4. I can rewrite 36 as 9 times 4. So I can write I to the 36th as I to the 4th to the 9th.
Which is 1.
What's up?
Nothing.
Okay. I was like, you can't ask me why I do something. Like, that's okay. You're allowed to question. What's up?
I get I to the 6.
The problem with doing I to the 6th is that that one doesn't necessarily simplify down to be 1 and get out of my way. You can do that, but you're just going to have a lot of in-between steps in there. The reason we were aiming for I to the 4th, and if you notice on all of these I have an I to the 4th, is because I to the 4th equals that 1. I to the 4th equals 1. So I'm trying to get something that's going to get out of my way. And I know if I get it down to 1, 1 just times 1 is anything, and it gets out of my way. You should still wind up at the same answer. You're just going hard mode. So on I to the 36, I know I to the 4th equals 1. So we wind up here with 1 to the 9th, which means what does I to the 36 simplify down to? 1.
Can the quiz be on there?
And it'll show up in the next bit. All right. Now we have this negative 1. You have a couple different ways to approach it.
Make it into a fraction.
Make it into a fraction. It is a negative exponent. That means this is going to become, in my denominator, I have 1 over I to the 19th. That's what the negative exponent does. We still need to simplify. So I'm going to split my 19 up into 2 chunks. It's still in the denominator. What can I do to split 19 apart into something that will simplify? Yeah. I to the 16th and I cubed. 16 plus 3 gets me to 19. I'd like 16 because it's made up of I to the 4ths. So, the I to the 16th, that's I to the 4th to the 4th, which means I to the 16 entirely simplifies down to be what?
1.
1.
Times
So 1 times I cubed. What does I cubed simplify down to?
negative 1 times
So we get 1 over negative I. All right, we're going to get back into our rationalization here for a second. Because I know that I is actually a radical, right? I means square root of negative 1. So right now, on that last one, I have a radical in my denominator. We're going to no longer let that happen. Because right now I have, and I can move the negative up, negative 1 over I, which is the same thing as square root of negative 1, right? I'm going to give us some more space, and then I'll zoom it in, because I know it's very small and very at the bottom. So 1 over negative I is the same thing as negative 1 over the square root of negative 1, right? That's what that means. We don't like to have radicals in our denominator. Like, that's a thing we're not going to do. We left one like that yesterday, but for the most part, we're not going to do that. So if I need to do something to get rid of the radical in the denominator, you guys remember what we do?
do we square both?
Not going to square. We don't have an equal sign, so I can't square both sides.
Like,
Multiply it by whatever our denominator is. I don't have a sum here. I don't need the conjugate. I just need a funky looking 1. We can only do multiplying both sides if I have an equal sign. I only need the conjugate if there is addition. So if we just have a radical in the denominator, we just multiply by that radical. Because when we simplify this, I have -1 times my square root of -1. That's I. We know that. My denominator is I times I. Square root of -1 times square root of -1. What's my denominator going to be? -1. Multiply top, multiply bottom. So this whole thing, I to the -19, simplifies down to be what?
I or
Just I.
-1.
The negative ones are obnoxious because we do have to rationalize them. It's just I.
So if we put square root of -1, it would be wrong.
It's not wrong, but it's not fully simplified. It's the right value, but we're going to switch them back to i's and just leave them not as radicals. So when we are simplifying I, in all of our answers, for all the ones we've gone to, what exponent should be on I at the end? What is the only thing? Just 1. No matter how many we start with. We have I to the first, -1. Negative I to the first, 1. Those are the only possibilities for answers. So if you wind up with an I squared, you're not done. If you wind up with an I cubed, you're not done. Yes, dear.
On the last one that we just did,
Yep.
on the 1 divided by -I, why did it turn into negative?
Oh, it doesn't matter where we put the negative sign because negative I, so you can do it that way. I'm just going to bring it over here. Whoa, wrong pen. Spoop. 1 over -I can rewrite as 1 time over -1 times I. That means the same thing, and so I can move that negative sign wherever I want. It doesn't matter where that is. I put it at the top because it makes my brain itch if I have a negative in the denominator. It's not wrong, and you could multiply by that. You're just going to wind up with a whole lot of weird signs if we're multiplying by -I and then also trying to simplify. Okay? Absolutely fine. I didn't even think about it, and having a negative in the denominator makes my brain itch. It's not wrong, it's just not good grammar. That's all it is math grammar. Okay? Questions on I? Just I. Because then we're going to go play with I. It does not start out bad, I promise. Because we're going to work with complex numbers. You've seen complex numbers before. You have. I promise you have. They look like this. A plus some number times I. So a number, a real number, plus a number times I. Can be ones, can be zeros. So the I might not be there. The A might not be there. These are outside the real numbers. Most of the math we do lives in the world of real numbers. Once we start throwing in I's, we have left the world of real and into the world of imaginary. Which I know we go, why? Because mathematicians got frustrated with the fact they couldn't finish solving quadratics. So they made up I so they could finish solving stuff. So it's literally imaginary. They literally made it up. That's why it's called imaginary. Okay, so this is how it kind of exists in the world of numbers we're used to. Not a thing we need to be able to recreate or look at. There's an image like this in your book if you really care and you want to see it. But we're normally living in the world of our natural numbers, our whole numbers, our integers, our irrational numbers, our real numbers. We're out here in a complex number. But now, it's okay. Just my magnetic bucket. I've crashed into this car about 8 times today. I don't know why. I'm just unaware of it today. All right. So what we're going to do is we're going to start with adding and subtracting complex numbers. They look like this. I was looking to have an unsharpened pencil up here. That is so helpful of me. To have an unsharpened pencil right here. Totally functional. Pens, swoop, pencils, marker, pens, marker. There we go. We're back. We're organized. Life is good. Boop. All right. So here are two complex numbers on the left-hand side. 3 plus 4i is a complex number. 2 minus 7i is a complex number. We are adding them together. What do we do? We look at these and we start to panic, and I know. I promise, you're making it harder than it needs to be. What if, instead of me saying 3 plus 4i, I said 3 plus 4x plus 2 minus 7x?
That would be 5 minus 3x.
Yes. Just use I. Treat it like a variable. You get the exact same thing. We're just putting the number without the I in front and the I at the end. My parentheses here aren't actually doing anything. It's all addition. So I can change what order they're in. I can put this as 3 plus 2, moving things around, plus 4. I'm switching back to my i's. 4i minus 7i. So what's 3 plus 2? 5. What's 4i minus 7i? Negative 3i. So we're going to minus 3i. Yes? Yes. That's your answer. Treat them just like variables. What's up?
Would I, like, X usually goes in front? Does I go in front?
Correct. I goes at the end.
Okay.
When we are putting them, best math grammar has it into that A plus BI. So we should have our answer looking like A plus BI. So our real number at the front, our imaginary number at the end makes our complex number. It does not have to be in parentheses if it's by itself. You are welcome to put them in parentheses. It is absolutely not wrong to put them, like if you want to do it like that, 100% okay. What's up?
Are we gonna get to the point where we gotta like multiply by
Uh-huh. That's why we talked about simplifying. Then we're going to do our adding. Then we're going to do some multiplying, and that involves simplifying. Okay? So we're doing our adding. Let's do some subtracting. Right-hand one is almost the exact same thing, except we're subtracting these two complex numbers. So what are we going to do? What do I need to do different on the right-hand one? Distribute the minus sign. So this is the same thing as saying minus 5 plus 3i. Distribute my minus signs. We get plus 1 minus 2i. And we're into exactly what we did on the last one. Combine some like terms. What is our simplified complex number?
Negative 4
Negative 4
plus 1 or I.
plus 1i or just I. Either way is fine. You can put the 1. You don't have to put the 1, just like you can put x. You can put 1x. You can put x. It does not matter to me. I told you, y'all were overthinking it. Adding and subtracting them, it's just like polynomials. It's combining like terms. It's just an I instead of an X. Okay? Questions on these ones? Because we're going to do different, because we can do this. Ready? Multiply.
Yay! It's time to celebrate.
Time to multiply.
Is it
The
same?
process is exactly the same. The only thing that's different is when we get to the end, we need to simplify using our exponent rules that we just did with our i's. Okay? So multiply it out. Usually distribution. You can box it if you want to, but either way. So on this first one, I'm going to take my 2, whoop, wrong pen. Keep doing that. 2 times 3, giving me
You remember?
6.
And then you simplify.
2 times minus 4i gives me minus 8i. 5i times 3 gives me 15i. And 5i times minus 4i gives me minus 20i squared. Okay? Just like polynomials, combine our like terms. So I've got my 6 minus 8i plus 15i. Gives me what?
7i.
Plus 7i. Minus 20. And then I see an I squared. We don't want to have any exponents left on i's. What does I squared equal? Negative 1. I squared is negative 1. If you need to work it through, absolutely fine. But I squared is negative 1. Well, now I have some more simplification I can do. I have 20 times negative 1. So we're going to have 6 plus 7i plus 20, which means our answer is 26 plus 7i. Any questions on any of these steps? Because I know it's awkward and weird. When we are multiplying complex numbers, we should always wind up with a complex number or a real number or an imaginary number. So some combination therein. We should never wind up with exponents at the end with i's. I's are only simplified when there's no more exponents. If you still got an exponent on your I, you're not done. Okay? So let's do the next one. Very similar vibe. Practice these. I'm just going to give us a little barrier here so I don't crash into them. So we're going to multiply together, do our distributions. We should get 8 minus I minus 16I plus 2I squared. Here, I didn't write it, but. All right, combine our like terms. I've got 8 minus 17I plus 2I squared. I squared means negative 1, but that means the whole term is minus 2. I'm going to write it in 2 pieces. I was like, you have a tendency to jump a step with me, and that is absolutely okay. That is the step process your brain goes. That's the process you write down. I often will write more steps than you guys need. Whichever lines your brain doesn't go to next, skip it. Totally fine. You do not have to copy exactly everything I'm writing. I just try and write as many things as I can, because for someone will need every single step, and that's okay. Some people can skip usually every other line, but that's not necessarily the case for everybody. So what's our final answer here? What's our complex number answer? 6 minus 17I. That's my answer.
Like, dude.
I'll highlight the other one just so we have it. So they match. So that was my answer over here. Okay? Questions on these ones?
The answer, you can't the answer.
Go Colts. Swoop. 2 more. These are the last 2 for today. Last 2 for today. So we've got kind of a combination operations on the left-hand one and more than one operation on the right-hand one too.
This is the same, like,
It's similar, but it's just like a harder polynomial because I have on the left-hand one, I have multiplying and then subtraction.
oh,
Okay? So we're going to need to distribute and then subtract. So we're going to multiply it out first. I got to distribute my wrong pen. I can never remember to switch back off that highlighter. Distribute the 3. So we're going to have 6 minus 15i. And then we also need to distribute this minus sign. So we've got some double distribution happening here. Plus 7 minus 3i. So, combine our like terms. What's our answer here?
So 6 minus -7.
Yes, 6 minus negative 7, which is also known as 6 plus 7, which is what? 13. What's my imaginary component?
negative 18.
Minus 18i. It's same thing when you write it down, whether you say negative or minus. Totally fine. Okay, there's our answer on that one. Right-hand one's a little bit more complicated because we have more than one multiplication here.
Wait, don't we pass the square first and then?
I say, remember your order of operations.
I always see them.
Either do it as an exponent first or write it fully out as a multiplication. Do not distribute that I in, then square. That is the most common mistake made on that one, is that we distribute the I in and then square it. In which case you have squared the I as well, and that's not what we're told to do. So you can either do this as a squaring, or you can do this as I times 4 minus 3i times 4 minus 3i. However you want to think about it. Now it's multiplication, and I can multiply the I in, and we stop at our closed parentheses because that's the stop sign when we distribute. I think it's easier to do it as the squaring and then multiply the I in, but that's the way my brain works. So that's the way I'm going to do it. I'm going to take this way and do it squaring. So I'm going to have my I out front, and I'm going to square my 4 minus 3i, which is going to give me 16 minus 12i minus 12i plus 9i squared. That's what we get when we square the 4 minus 3i. Which gives me I times 16 minus 24i plus 9i squared. So I took the square route. If you want to do the multiplying route, you can do it in whatever order we need to. So I took this chunk and squared it and got this bit, which is this bit. Now I'm going to do my multiplication before I do too much simplifying, just because I know I'm going to have to simplify anyway, and just simplify one time. So I'm going to do my distribution and then simplify, but if you want to simplify first, then distribute, then simplify again, that's totally fine. So we're going to wind up here with 16i minus 24i squared plus 9i cubed. And now we need to simplify because I have exponents on i's, and that's not good. I'm going to change our view for a second, and I'll get us a little bit more space. Done. There we go. All right. So a couple pieces in here we know. What does I squared simplify down to be? -1. So we have our minus 24 times -1. What does I cubed simplify down to be? -I. So this is 9 times -I. And our 16i is just hanging out. Okay? Good on time. Love this. All right. So we're going to finish simplifying this. I've got my 16i plus 24 minus 9i. What does this simplify down to? What's our final answer? 24 plus 7i. Okay? That's your answer. Questions on that one? All right. I do have your quiz ones. If you would like those back, you can have them now. The quiz one, and you can have and keep. So we've got Alex. It's going to be fast for me to call your name. So we have 2 minutes to dismissal. Jennifer. Grace.
Wait, did you say?
I have the boards, but I haven't. I don't think I've gotten it quite ready yet. I have it. I got my hands on it last night. It's in my pile. Grace. Tyler. David. Alpha. Oh, sorry. That's Tyler. I think. Jennifer. Jennifer. All right. Alpha. David. Tyler. McKenna. Evan. Anthony. Aaron. Risa. Carlo. Elena. Herbie. You, Elena. Anthony. Samara. Colton. Jaden. Daniela. Claire. Liz. Teresa, Samara, Amadou, Carlo, Grace, Wow. Marvin, Maddie.
I don't know what I did here. I did that wrong.
Space. Ralph.
I did this right.
Sorry. There we go. All right, those are all the quizzes. Samara and Amadou, we still got your quiz. Amadou. Y'all, hard so we can get our quiz. Thank you. That's quiz one. You guys can have that. You can keep that.
I'm so excited like this time is
So it would be,
oh yeah,
it's not less and it's
that's how I became such a friend. I got that wrong.
out of 20.
Yeah, I was
Nope, they're out of
you
20.
wasn't a really good friend. No, then my mom is gonna be like, why did you get an 11? I'm gonna have to be like, my dumb friend who copied me.
So
And you realize after
you
this.
have a lot of good pieces.
Wait, I'm gonna show Miss Sitzman my grade. She's gonna be so proud of me.
Good in this class if I actually. The effort, yeah. It's algebra.
Combining here, combining with problem.
I'm gonna do better next.
Oh, no, it was the 32 times 1, meaning the 33.
You don't see
We'll
the book.
multiply. Trig is next semester.
Yeah.
We will do trig stuff next semester.
That's geometry, right?
Sines and cosines and all those graphs. If it is not less than, can it be equal to?
Oh.
Yes,
oh,
yes, it can.
that's true.
Yes, it can.
I see.
So if x is less than 3, will your argument be negative? Really? If x is 2? If x is 2, will this piece be negative?
Yes.
Yes. So to get it without the absolute values, we take that term, parentheses, minus n out. That's true. Okay? Yep. That one was the whole model of, I'm not entirely sure what was happening. So you have a lot of things that were great, but we had something off in our exponents in here, because your fraction's fine. We have something off in our exponents. I do not remember every one of my head. Okay, so if you keep that, we can keep looking through that as we have time, but as you can see, we don't often wind up with tons of time.